All right, well, I think we're about ready to get started. I'll go ahead and get started. We're gonna talk about deploy, release, CI/CD, oh my, or as I call it, kind of DevOps for the rest of us. It seems every week that there are a lot of different new terms that kind of appear, to describe the different DevOps tools and segments, the ideas, the practices, et cetera. But I think the question for me often is like, are any of these really new? You have CI/CD, you got progressive delivery, AIOps, GitOps, TreeOps. Okay, it's not really a real one, but I mean, maybe next week. And I will absolutely confess that as I was building this talk and started doing this about a year ago, I did in fact register devtreeops.com and treeops.cloud and put a coming soon-ish website on it. So I have over, this is kind of illustrates, I have over 20 domains that I've registered and done nothing with. Hi, my name is Jeremy Meese. I have a problem. I'm the director of DevRel and Community at CircleCI. That's not the problem. The problem is that I have domains that I've not done anything with. And you can find me on, the Twitters, timeline.jaredog.me, which I don't keep up to date as much as I should, but you can find me there. So with all these different terms that are out there, are they all the same? Or are they just kind of, reimagining the buzzwords from last week? And sometimes it feels like companies, they like to kind of chop up a lot of these buzzwords, throw them all together, and voila, they have a new, DevOps term or a DevOps salad that's born. So as we think about, the DevOps lifecycle, there's kind of the hope of how we implement this thing, and then there's really the reality. John Allspaw called this the work is imagined versus work is done. In this tweet that he sent over 6 years ago now, and it really illustrates all of my attempts at coding. Really, is I feel like I'm going to get there to the finish line, and next thing I know, I'm I'm drowning in the middle of my own inabilities to do so. And this image really illustrates, I think, where we get, when we think about the DevOps lifecycle, how we try and put things together within our teams. So there's the hope of how we're gonna, do development, move out of waterfall and do this, agile type of delivery. But reality is, I think, really boils down to that bottom image is very much where we kind of sit. So what I want to do here is I want to start with kind of some of the foundational, more recent kind of trendy terms that are out there for DevOps within that segment, and then kind of finish with kind of a more foundational kind of elements of DevOps. So we'll start with AIOps. So Gartner, they coined the term, which is short for Artificial Intelligence for IT Operations. And since they coined the term, they get to define it, which defined it as combining big data, machine learning to automate IT ops processes, including event correlation, anomaly detection, and causality determination. Sounds like the architect from the Matrix kind of walking through everything there. But another way to put this, Wikipedia had, that kind of goes more, it's an industry category for machine learning analytics technology that enhances IT operations analytics. So these tasks that they're talking about, they are automation, performance monitoring, event correlation, among others. And there are two main aspects of what an AI ops platform kind of looks like. So you have the machine learning piece, and then you have the big data piece. And in order to collect data from that big data platform, so that you can observe it and then engage with it, you kind of have to shift away from segregated IT data towards kind of this more holistic machine learning and analytic strategy. The goal there is then to make sure you receive continuous insights so you can continuously fix and improve via automation. So to kind of simplify things into one grouping of images, that's relatively simple, right? It's kind of simplified. Makes a little bit more sense. It's an AI ops platform that helps aggregate, make sense of all the different data sources within your platform, within your code, with everything that you're doing, identifying all the links and all the interrelationships between those kind of different silos within your platform, and then helps to kind of predict events. hopefully prescribe solutions that are going to work, and then act based on kind of that real-time data streams that are coming in. GitOps. So GitOps is, it's relatively new. There isn't even a Wikipedia page for it. And I did just check, just so we're clear, before doing this again. It has just started appearing kind of in the last few years, but it is newer than AIOps. There's not even a page for if you type in Git space ops on Wikipedia. If you type in GitOps, it does appear as kind of a subset of the larger DevOps, but even then it's like a sentence. So there's not really been a whole lot of effort put into defining this, at least on Wikipedia. And I've been doing this talk now for almost a year, and nobody has kind of stepped up to kind of jump in and fill that void. So I feel like this is probably a very serious oversight by the DevOps word salad gods, and one of them should rectify it, which I'm sure at some point one of them will figure out who's going to do that. But so Weaveworks, again, they coined the term, so they get to define it. They say it's a way to do Kubernetes cluster management and application delivery, and that it works by using Git as a single source of truth for declarative infrastructure and applications. What it does is it attempts to take this, like the existing continuous delivery and infrastructure as code principles, which are non-tool specific, and then repackage them down into like tool specific things. And so, that causes a lot of different controversy, because, DevOps tends to be, it's not about the tooling, it's about the processes, it's about the culture, it's about the things that you're going to put in place. The tooling comes afterwards. But by trying to create something here, it definitely creates a lot of controversy whenever somebody mentions, asks on Twitter about GitOps. That's becomes the topic for the week. So, but it is, it is out there. There are some companies that are, attempting to do a lot of different things with it. But yeah, so that's GitOps. Now, DevSecOps. So Phil Richards, in a post on ThreatPost, described it like this, in that it's very much a way of it's putting security at the forefront of the developer process, and as a whole, kind of ensuring that good cyber hygiene remains top of mind for developers and operators from start to finish. It is a definite, and has been kind of for a lot of companies, kind of a big shift in process, a shift in mindset. And it encourages organizations to kind of find the best possible approach to developing secure code and applications. Wikipedia does give a little bit more data here, talking more about it's allowing security practices to be integrated into the DevOps approach. I think a key piece here is like each delivery team is empowered to factor in the security into their software delivery process, and that security, and testing, security practices and testing are performed earlier in the development lifecycle. And that's kind of where this term shift left, can definitely be used. That phrase has become pretty common. It really just describes like an approach to software security and other things that places kind of an importance on implementing those practices earlier in the process, instead of them being kind of a throwaway of like, well, it's not the operator's responsibility, or it's not the developer's responsibility, it's the security team, so we'll do that last. Well, the idea is it needs to be a part of everything that we do. So that's where DevSecOps kind of fits. There are many tools out there, which kind of the desire is to give developers the resources, the power to kind of implement security as that important part of the life cycle, and not just kind of as that, like I said, as that afterthought that we throw over the wall. Now, progressive delivery is this one thing that's started to kind of take shape over the last few years. It was coined by James Governor of RedMonk, who after he heard about Microsoft's progressive experimentation approach for how they did feature rollouts, and he wanted to kind of capture this wide range of new software development practices that were starting to come up that went kind of beyond just thinking about continuous integration and continuous delivery. Adam Zimmern, at the time, who was the VP of product at LaunchDarkly, he realized that feature management would be a key enabler of this new kind of progressive delivery model, which is defined by things like dark launches and feature flagging and testing in production and canary launches, blue-green deployments, A/B testing, so on. Those terms that we hear were very much a part of kind of this new progressive delivery model. So there are two kind of things which make up the methodology around progressive delivery. One is kind of this release progression, and that refers to kind of taking the number of users that get exposed to and really impacted by new features at a pace that's appropriate for the business. So starting out, you can perform release progressions in a number of different ways. You could do like a targeted rollout, so it's only going to go to certain people maybe that you've identified with that use your app a certain way. Or there'll be like canary launches, ring deployments as it keeps getting broader and broader, percentage rollouts, so on. So you define it as what works best for your business, but you slowly roll it out to minimize the impact. And you kind of think of like a release progression as kind of like a progressive deployment or a progressive release. The second piece is kind of comes down to like progressive delegation. And this is like, the idea here is you're progressively delegating the control of a feature to the owner who is most responsible for its, the outcome or the success. So if you think about this, when you're initially developing the tool or the process, whatever you're doing, the engineers, they're controlling that feature. They're getting it done because they're the ones that they're responsible for building and testing it. But once that's been tested and it's done, then it makes more sense for like the product manager to step in and own that, because then they now control the process of launching that feature, and then letting engineers get back to doing the engineering, and it's this idea of progressively pushing the delegation to the people that are most responsible for its outcome. Now, when we think about release and deploy or release and deployment, over the years I've seen a lot of IT professionals use this wrong. And confusing like the words deploy and release, and there is actually a lot of like a big difference, and they tend to get kind of confused. And so I'm going to kind of break down some of these between like what a release is and a deploy, how they're independent, crucial steps in your software shipping process. So deploy. So deploy or deployment, that's going to include all of the like technical activities that are needed to make a software system or feature available to be used. So if you think about like a Docker container that's running in a pod on Kubernetes cluster, so we're just going to use some buzzwords here and throw them out there. It's passed all of the tests in the CI/CD pipeline. It's now ready to receive traffic from production users, but it's not actually receiving any of that traffic yet. This part of that process is you've kind of making sure the new version's healthy, it's running smoothly. You're taking all of the kind of the technical checks and balances and placing them there without any of the risk that can be involved by actually starting to serve production data to it. You can kind of think about like deploying a piece of software is, or really should be, a very mundane and risk-free activity. And deployments tend to be, they're related to the overall kind of continuous delivery process, but they're going to be more automated. You want them to be more automated, getting them ready to be released. Now, when we think about release, that's going to come after the deployment. That includes all the activities that are needed to move part of or all of the production traffic to the new version. So, this is where all the risk can happen. This is where all the things can go wrong, is when it's actually starting to be released to the public or released to production or to production traffic. So this is where this is really the risky activity that has to be done in a really slow and controlled fashion. Release cycles is really kind of just this overall process of deploying software to an environment and then ensuring that all of the deployments in that release are functioning, performing as expected. You could view release processes in management as kind of being related to the continuous delivery concept, but they're individual processes themselves. Now, continuous integration, continuous deployment, continuous CI/CD. That's rooted in agile methodologies. And it really embodies kind of the culture of a team or a company's commitment to automation and DevOps principles. Agile methodologies, generally that contains a set of operating principles. You think about the Agile Manifesto. Anything that has a manifesto, it's got to be good, right? It's based on 12 of these kind of methodologies, operating principles, and then like a collection of practices, which the idea was to enable dev teams to release quality code more frequently and reliably. Now, those principles themselves have brought about kind of different agile software development frameworks. There's lean software development there, Kanban, Scrum, and everyone's favorite casserole, Scrumban. Hopefully there's a laugh. There was only a couple chuckles. Let's have a big, I had never actually heard of what Scrumban was until somebody mentioned in a recent talk, and I was like, oh, okay, guess the teams I worked on never did that right. So you know what it is, great. Back to this, but it's brought about like a variety of different agile software development practices. There's some fun ones in here. There's the planning poker, and I actually, I didn't know what that was also until someone else kind of let me know about that. But one of the things that did come out of this agile movement was continuous integration. You can kind of see that on the list there. And the person that was kind of the main contributors to that was this guy by the name of Grady Booch. Now, Grady, he was one of the originators of object-oriented programming, and he was the founder of UML. And he first proposed the idea of CI in 1991 in this book entitled Object-Oriented Analysis and Design with Applications. Now, his method advocated for more frequent use of classes and objects in programming in order to simplify the design. His view or his version of kind of this continuous integration didn't suggest releasing multiple times per day, though. That came in 1997. That came with this idea of extreme programming, which was built on the Booch method, and that advocated itself for releasing multiple times per day. It really kind of changed the game. I don't know if anyone here remembers this book. I remember I had it on my desk when I worked at Sprint. There was a lot of really great stuff there. The crux of that method was just that it was taking already standardized concepts and principles and paradigms that we had for writing and releasing software and then going way further with them, or to the extreme, which is why it was called extreme programming. So we started to see coming out of this was shorter release cycles, extensive code reviews, or we call them pair programming now, unit testing, acceptance testing. All of these started to come out of extreme programming, and they're now pretty standard because of it. From here, we started to get kind of a lot more and more kind of methodologies that kind of built on this. But the one goal was still in mind, was trying to make it easier to write clearer, higher quality code, get it out to the users. And while we recognized that all this needed to happen, we really didn't have the tools at the time to really make it happen on the scale that we needed, at least not easily. Now, cruise control, is that one, anyone remember that? There's only a couple that remember that one for sure. It was an open source tool. It was the first one that made continuous integration easier. When we look back now, it really did. I mean, easy is a very interesting term. Back then, it was the first of its kind. And so, compared to what we see today, it was really primitive and prehistoric. But it was a game changer 20 years ago. And I still see some evidence online of people kind of still using it in some form or fashion today, sadly. But it was revolutionary when it was released. For the first time, there was this system that could be installed and stood up by yourselves or by a team to automate the management of builds and allowing developers to release way more often, and it even would integrate with your IDE. So depending on the IDE you had, you would have to have a specific variant of cruise control. So if your IDE was Eclipse, then you had a Java-specific variant. If you were using Ruby, you had a Ruby variant, and so on. But eventually it was overtaken by Hudson, which then became Jenkins. That is still very widely used today. It supports a lot of different languages. It can be made to do just about anything that you want it to do. It has an enormous community around it. When you do run into difficulties, chances are there's someone else who's run into that, and you can go and find the issue, or they've had to create something to fix it. You can use that. It's relatively stable, relatively secure. It still is pretty popular. But the downside for things like this that have become hosted solutions that kind of stand up and to kind of take a mind of their own is that the way that we're building software, the way we're deploying it, the way we're using it is changing. Jenkins is really kind of starting to show its age as others like it. There's Travis CI and few others are kind of still on that old concept of host it yourself. But there are cheaper, more available options that are in the cloud to do this that actually, like I said, move back to the way that we do stuff now. Circle CI is one of those cloud services. There are others. They're built so that you don't have to really babysit your CI process, service, or your infrastructure, letting you kind of get back to the business of writing software. If your business is not meant to, like, if you're not developing a CI/CD platform, then you probably shouldn't have a CI/CD team inside your company. They could probably be better used integrating back into your, building your core product and using a cloud service that would help speed up what you're trying to do. In all of these, they all kind of have, they support lots of different languages, sometimes all of them that are out there, different build environments. They already know how to build out, deal with other cloud native technologies like Kubernetes and Docker. And so you don't have to learn that. You just can just set it up and it can go. So using that cloud service is going to be a lot more flexible and lower maintenance ultimately for you. Now, many years ago, thankfully, Microsoft Visual SourceSafe, who all used Microsoft Visual SourceSafe? Who all regrets having to use Microsoft Visual SourceSafe? Okay, at least one of us in here. I'll be the second one. It was great for what it was. I mean, when it came out, it was great. It was allowed for, the attempt was kind of keep you from working on code that someone else was doing. The idea, you check that out. It operated a little bit differently than what we have come to use with Git, but that was the idea, was to, make sure that you weren't working on code that someone else was working on. In theory, that was good, but it usually did devolve into going on a hunt for the developer that decided to check out the entire directory instead of just that one file, only to find out that they had gone on vacation and you had to get IT to take care of it. Those are real problems. And would often come back to bite you when you got into the QA kind of piece, massive loss of productivity. But there is a better way to do development. Enter CI for the continuous integration. It is the practice of merging all the developers' working copies to a shared code repository, which means that you're merging code changes often, so the team itself is more informed about what each other's code base looks like, the potential future conflicts that might arise. And since code base changes are being merged often, it's important to run those automated tests that are validating that those changes in the builds are quality code that aren't going to cause any issues. So as you're pushing your code base upstream, those automated tests, they get run to ensure that the code that you're pushing is actually of quality. Then finally, we're making sure that the merging of these changes are frequently done to the production branch or to your release branch. And this is kind of where this idea of fail fast and often comes in. It's very important because it gives your development teams the ability to know when stuff is broken, and which is invaluable. If you think about the ability to get to faster fixes, ability to not push code that is going to break your customer's way of working, it really helps you kind of get to the speed that, in a sense, once you're writing your code, it's quality and it's getting deployed, and you're able to push it upstream, let the automation take over where it needs to be, validate the builds and what. Now, continuous deployment is really just basically automation. The goals of CD and producing software releases are, it's generally going to be automation, efficiency, reliability, reproducibility, verification of quality, through continuous testing, which everybody should be doing. The overall chain of process here generally gets called a pipeline, and that helps us with releasing our software faster by automatically getting the source code changes, running them through the building, testing, packaging, and other related operations to produce that release. In most cases, it also means you're delivering smarter. You're lowering your risks to the risk to your release process. The code and the software that's getting released should also be at a higher quality. And by using these continuous delivery mechanisms, it can help you lower your costs for actual buildable items, such as time spent delivering your software, multiple infrastructures like QA and staging and production and whatever you want to call those. So, get this question: is CI/CD a tool? And so, in the spirit of every answer to every DevOps question, it depends. Much has changed in the way that we do, the developers ship and build code. So when you're implementing CI/CD, you're really implementing the practices and principles, which aren't really about the tooling. It is important that you and your teams, sit down and understand, how you're going to be implementing these processes and principles, because CI/CD aims to break down those walls between dev and ops and get everyone on the same page working together. You don't have to implement CI/CD all at once. Instead, you can kind of think about that very process of being something very iterative itself. The systems and tech that are currently in place for your organization, combined with the culture, which you might have to reform that first, all of those things dramatically kind of influence the customization or the tools that you need to actually implement once you've made that change in the culture. So the fundamental tenet of CI/CD is quite simple: commit and integrate your code often, daily at a minimum, and such a small change in your software development process can really yield big. So, and when we talk about speed, obligatory, you have to put the Top Gun one up there about CI/CD gives you speed, getting amazing speeds as a business, become a high-performing team. So when we think about high-performing teams, it's important to have one, important to be a part of one. Much like these, who I'm assuming are product managers. I'm sure that's kind of what at their on-sites, that's kind of how they practice product managing. Over the last 3 years or more, we have been publishing research that we've been doing around what it means to be a high-performing team. We reviewed over 300 million workflows over that time, over 40,000 organizations, almost 300,000 projects. We've been able to kind of identify specific CI/CD benchmarks. So these, when it looks like what a high-performing team is, this is where you're merging, on any pull request, your throughput is just as at the speed of your business. The duration of time is, of your builds, 10 minutes or less. Mean time to recovery, less than an hour. Success rate should be 90% on your default branch. We don't track it and don't suggest you track it on your development branches, because things should fail on your development branch because you're doing new development, you're doing new ideas. But on your production branches, your default branch should be 90% or more. If you want to get kind of the full report around the data, we call it's the State of Software Delivery Report. You can either go to circle.ci/SSD 2022, or you can scan this QR code. You don't have to sign up for anything. You don't have to give us your email. You just click the button that says download. So that's that. Definitely, we're here, stop by the booth. We'd love to talk to you about kind of what a high-performing team looks like for CI/CD. And thank you. That is it. Be sure to follow all that. If you have feedback or just want swag, go to circle.ci/Jeremy. So thank you very much. I guess we're at the end. If anyone has questions, feel free to ask them. I'm only keeping you from lunch, so if you want to go to lunch, go. Yeah. Yes, so it's all, any jobs that are run on our platform is part of that data set. It's all anonymized, but it is the largest grouping of data of any of the reports out there. And it's dealing with, like, the state of DevOps reports, the DORA reports are amazing. They've been extremely influential to kind of where we are as an industry. They are still surveys. And Dr. Forsgren has done a great job of, and her team, of refining the questions and making sure that to hopefully remove some of that bias, but it's still relying on what your memory is of what you did last week. And so what we've done is we've taken that and looked at for ourselves, look at the data and see how long builds are running, see what the mean time to recovery is, all of that. And then we've gone and looked at, okay, so how does that match up to that report? And what they've identified as high-performing teams, 50% of the people on our platform fall into that. So it's a good measure where we're going, okay, this is definitely validated by not only industry ways of looking at it, but the actual data itself. So what makes a high-performing team? It depends. Just had to throw that out there for giggles. The answer to that is if you have a low success rate on like your default branch, that tells us there's a lot of things breaking. That also points to you probably don't have a lot of good testing. And so we're able to look at that data and understand when you mash it all up, what that looks like. Now, and I do a talk on like the metrics report and on high performing teams, so I'd love to talk to you more about that. But the short answer is that you have to start with the baselines for your business. Because not like when you think about the throughput, you think about duration, well, it should be 10 minutes or less. That's great. But if you're building a very monolithic application that's in C or in Java or some of these big like compiled languages, that could take long, and you don't have a lot of room for movement. Now, you can split jobs up, you can do concurrent jobs, there's things you can do, but the reality is that you may not be able to get to that 10. But if you set the baseline and then start making sure that you take the different steps to streamline, you can get closer to that. And that's where you can say, okay, well, our benchmark was here. This was our baseline. We're getting closer and closer, and you can set that. So every business, you're not the Netflix, unless you are. I don't know if no, okay. You're not Google. You're not those that have these huge organizations and they're deploying thousands of times per day. You're not them. You may be a small startup, and you can fit all of these, or you might be a large company. You're unique. So it's understanding what your business is doing first and then make changes from there. It's kind of like it's not about deploying a new tool. Tool's not going to solve your problem until you've identified the culture and the processes that have to change, and then you fit that in. So, cool. Anything else? I will probably be by the booth, or anyone at the booth could answer questions too on any of that. So thank you. Appreciate it.